Hello, dear authors and invite guests. Welcome to technical session 3A. Good morning, good afternoon, and good evening, wherever you are. It's my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems, Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. And we wish everyone and their families a protected time, and we will all together pass this soon. We hope you will enjoy these 2 days of knowledgeable and interactive sessions. Just before we get started, I would like to introduce you all to the chair for this session, Dr. Pancham Shukla. I'll just share my screen. Here we go. So hopefully everyone can see that. So there we are. So Dr. Pancham Shukla holds a PhD in electrical and electronic engineering from the Imperial College London and MPhil in electric and electrical engineering from the University of Strathclyde in Glasgow. He holds a ME in electronic and computer engineering and a BE in electronic engineering from Sardar Patel University in India. Dr. Pancham Shukla is a senior lecturer in communications, technology and mathematics at the School of Computing and Digital Media. He is also a course leader for computer systems engineering and robotics and a bachelor's in engineering and electronics and Internet of Things. He holds a bachelor's in engineering, and Dr. Shukla is a vice chair of the Research Student Progress Group and PhD in degrees. In recent years, Dr. Shukla has been focusing on applications of signal and image processing in computer vision, machine learning, robotics, Internet of Things, and cybersecurity. He has organized conferences and served as technical session chair, along with reviewing many international conference and journal papers. Prior to joining London Met in 2007, Dr. Shukla worked as a research fellow in the Applied Digital Signal and Image Processing Research Centre at the University of Central Lancashire and as a research associate in Communications and Signal Processing Group at Imperial College London. So just going to start with our first presenter, who is Zlatinka Kovacheva from the Bulgarian Academy of Sciences in Bulgaria, and her paper title is called A Multi-Dimensional Rendering of Error Types in Sensor Data. So whenever you're ready, Zlatinka.
Yes, she was with us, but might be just right now. She is not in the virtual room.
Should we move on to our second presenter?
Yes, so whenever she will make, we will take her presentation.
Okay, no worries. So I'll just introduce our second presenter instead. So our second presenter is Melanie McCaig from the University of Guelph in Canada, and a research paper is called A Scoping Review on Value Creation from Collaborations and Enabled by the Internet of Things in Agriculture. So whenever you're ready, Melanie.
Excellent, thank you. So I will share my screen. I feel like those are the most said words in the last year. Oh, time to share our screen? Okay, perfect. Come on. Excellent, well, thank you. Welcome, everyone. Thank you for being here today. My name is Melanie McCaig, and I'm from the School of Computer Science at the University of Guelph in Guelph, Ontario, Canada. Today, we'll be presenting my team's paper titled A Scoping Review on Value Creation from Collaborations Enabled by the Internet of Things in Agriculture. So, automation on the farm can improve well-being through increased time, efficiency, and animal and crop health. Specifically, robotics and sensing technologies can increase production, reduce costs, and improve product quality. Although agricultural innovations and technologies are available to streamline farming practices, many farmers are left out. These technologies often evade older farmers due to the lack of financial resources, literacy, and technological skills. This pressure is further accelerated because the data indicates that farmers are working longer hours than historically and are experiencing labor shortages. The adaptation of farming technologies and policies representing the farming community's needs could help keep the farming demographic more engaged and productive. As farming technologies are critical for the evolution of the farming industry, technological innovation provides a chance to meet future farming needs. However, this goal will not be possible without increased investments, perceptive policies, and partnerships. These collaborative partnerships capitalize on the opportunities to reduce poverty and food insecurity while sustainably maintaining productivity and raising yields. To combat these issues in agriculture, partners must increasingly utilize the international collaboration and information technology tools, which includes the Internet of Things, which is an emerging technology that will have an extremely high impact on the ag tech sector. Collaboration has been deemed as the future of farming, citing it as necessary for achieving efficiency, scalability, and agility in changing markets and value chains. So for this paper, this review will examine the research themes surrounding value creation, collaboration, and Internet of Things in agriculture. These objectives amalgamate into our main research question: what does the literature tell us about value creation from collaboration enabled by IoT in agriculture? This analysis contributes to the literature in various ways. This study provides a better understanding of the current types of research and displays significant themes and concepts. It also clarifies avenues for future research in areas relating to collaboration and the role of IoT in value creation in agriculture. A scoping review is presented to provide an extensive overview of the literature, to collect and map key themes, and to inform whether additional research may be required. The process of our scoping review can be displayed by the Prisma flow diagram outlined here in Figure 1. This process was designed by the Jonas Briggs Institute, JBI, who created a manual that documents their scoping review process. So we followed their process. The first step in the protocol was to conduct a search using 2 or more databases. In this case, it's shown in the identification section. This study utilized the databases of ProQuest, Web of Science, and EBSCOhost. The chosen keywords were collaboration, value, IoT technology, and agriculture. Each database searched the terms simultaneously. The second step, as shown in the screening section, was to analyze the articles to identify new related words to provide a secondary search of the 3 databases. This step is shown in the screening section, as I said. For EBSCOhost, Web of Science, and ProQuest, the search field was limited to works that were written in English, but they were also open. So we identified all study types and all years of publication. In the third step, the authors reviewed the articles reference lists to identify other relevant articles. Following this review, all duplicates were excluded. This step is shown in the eligibility section of the diagram. Papers without a significant emphasis on IoT were excluded. Then at the end, you see, under included, it shows the final 37 articles. And these 37 articles were used in our analysis. So the results. We found that value creation and value is referenced in the articles, but not defined. The articles refer to value creation as an opportunity or as a result that can be improved through certain conditions. The term value was frequently cited, but not typically referred to as a measurable outcome. Value is described as either a tangible or intangible benefit. Tangible benefits include trade value, whereas intangible benefits include education or the treatment of animals, or, for example, the intrinsic value of big data, that is the unexpectedness of the insights that it can reveal. So very general. The articles also do not possess a central definition of IoT, with many not attempting to provide a definition at all. However, several reference the IoT as a dynamic global network of infrastructure that was connected to the web, very, very generally. Another relevant theme that we found in the literature was that although collaboration among farming participants is beneficial, with company reports claiming to have utilized it, the current structure of the agriculture environment has not attained collaboration enabled by IoT. However, what constitutes collaboration was also not defined. Instead, these articles use terms synonymous with working with others, such as well, there was a collaboration with researchers or in collaboration between the central authority and the local government, also very general. Further, in our results, we mapped them to show how the publications by each year. Among the 37 selected articles, there was 1 article each from 2010, 2012, and 2015. There was 8 articles from 2017, 11 articles from 2018, 13 articles from 2019, and 2 articles published as of April 2020, which is when we did this study. These results show that the topic is current and of increasing interest. As you see on your right, figure 3, it displays the selected publications by location. Top locations include India, China, and the United States with 6, Italy with 4, and Canada with 3. Other locations include England with 2, Denmark with 2, Sweden with 2, Australia with 2, and 1 in France, Czech Republic, Iceland, Romania, Spain, New Zealand, the Netherlands, Finland, Poland, Austria, Greece, and Wales. As you can see by this wide range of articles, it is of global importance. In fact, 6 of the articles were produced in more than 1 location. The following visual represents the types of research and methodologies that were conducted amongst the articles. Many of the studies did not include a method, being categorized as either a conceptual study or an industry report with 14, as not an official study, which included newspaper magazines, wire feeds, or trade journals, 12, a comparative research with 1. Of the remaining studies, the methodology was either quantitative through surveys with 6, or qualitative through case studies, interviews, and constructive research through 4. The lack of empirical studies suggests that more testing is necessary for the growth of this domain. To better understand what these articles were talking about and the viewpoints of these articles, the 37 articles were assessed and organized into economic, social, legal, operational, and technical themes. Articles that were categorized as social described a social network of relationships or relationships attributes. The legal discussed laws and policies and regulations. Technical explained the mechanical side of the technologies. Operational described the supply chain process, and economics described the business, economic environment, or other factors. Of the 37 articles, 32 were categorized into more than 1 field. The classification totaled economic with 20, legal with 12, social with 21, technical with 25, and operational with 18. These factors were necessary to consider when creating a conceptual framework of the agricultural technology environment. Among the articles, other research questions were raised because of collaboration and value creation enabled by IoT in agriculture. The additional questions that were raised primarily centered around the concerns of the ownership, privacy, and misuse of data. Therefore, when studying collaboration in this realm, one cannot overlook these concerns. Problems included data ownership, mismanagement of the data, power asymmetry in the industry, and how the information is shared. So discussion and conclusions. The scoping review aimed to answer the research question, what does the literature tell us about value creation from collaboration enabled by IoT in agriculture? The results revealed multiple insights about the field. First, as you can see on the top left, there is a limited amount of literature on value creation from collaboration enabled by IoT in agriculture. This deficit is apparent by the small number of articles obtainable for inclusion in this study, with 37 papers being applicable. Many of those articles were not subject to peer review, as the search included news articles in magazines, newspapers, wire feeds, and trade journals, and industry reports for a wider breadth. So that's really unfortunate. Second, many of the articles were published in the last 3 years, with a number of publications increasing each year. Although there is a lack of published work, there is recent significant interest in the field. The identified qualitative and quantitative works should be used as a reference point to expand the domain. Additionally, areas have been studied in 21 different countries. The articles frequently mention the government's inclusion as a partner, which seemed, again, the topic of global importance for many governments. Third, the literature recognizes that collaboration among farming partners is beneficial, but at large, collaboration enabled by IoT is in its initial stages. There is a request for further collaboration, as becoming a leader in IoT can result in a competitive advantage. These preliminary stages appear to be providing a variety of benefits for companies, farmers, and the governments involved. However, a theme in the article states that power asymmetry exists amongst the farmers. The farmers' concerns relate to the ownership, privacy, and the misuse of data. Therefore, we must study these problems further. For example, a framework is needed to understand the system in which these issues occur. Our paper recognizes the themes of economic, legal, social, technical, and operational, that are necessary to consider when understanding this framework and getting a better understanding of this industry. Lastly, many of the articles do not associate value or collaboration with a measurable outcome, or to determine a well-accepted definition of value creation, value, or the Internet of Things in agriculture. Articles frequently use the term as to improve value creation without pertaining directly to it as a measurable outcome. Value creation, value, in the Internet of Things was either not defined or had varying definitions. This absence of structure within these terms suggests it is an underdeveloped area. Bringing additional clarity to these topics is a necessary next step. Therefore, our recommendations. We recommend that more research is required to advance the field of collaboration and the role of IoT in value creation in agriculture. First, the current discourse of collaboration and value creation in the agriculture realm should be mapped to capitalize the benefits and further bring to light the concerns relating to ownership, privacy, and misuse of data. Secondly, the reports generated from this review were largely from companies and government perceptions, with little input from farmers directly. Farmers are likely to have a very different perspective of value and collaboration, as technology and time require a significant return on investment for these farmers. Finally, scholars could utilize qualitative and quantitative methods to understand the mechanisms and outcomes of these collaborations. These studies are critical to increase the number of academic publications and expand the theoretical and practical value creation domain, and also to keep the farming industry strong. Thank you.
Thank you, Melanie, for your presentation. I'm just going to move to Dr. Shukla if you've got any questions in regards to that.
A very nice presentation, on spot, 12 minutes. Thank you.
Thank you. I practiced. Thank you.
It's a very interesting paper, and all questions are relevant, especially the holistic framework. I think this paper will push various disciplines to talk together and come up with something that is holistic in nature in general about the collaboration and value creation. So I really like this research. Well done.
Thank you. I really appreciate it.
Any questions from audience?
So if anyone in the audience does have any questions, please use the chat function, and hopefully we can do that. So we're just going to move on to our next presenter. We're actually moving back to Zlatinka. Thank you very much. So Zlatinka, if you're here, so just to reintroduce her, she's Bulgarian from the Bulgarian Academy of Sciences in Bulgaria, and her paper title was Multi-Dimensional Rendering of Error Types in Sensor Data. As I think I might be having a few technical issues. In that case, we'll move on to our next presenter. Our next presenter is Rolando Armas from the International Associated Laboratory, LIA MODO in Ecuador. His paper title was Identifying Key Quality Features of mHealth Applications, Unsupervised Feature Selection Approach, MARS Case Study. Rolando, if you're there.
Yes. Hello, everybody. So I am going to share my presentation. Okay. So I am going to introduce our work. So our schedule is conformed by these 4 points. So first, introduction. Okay, software quality implies accomplishing the user's needs by combining with software features. For medical software, quality assurance and measurements are indispensable elements to provide user satisfaction. Mobile App Rating Scale, MARS, is a specific multidimensional measure for mobile health apps and provides a health domain evaluation criteria. MARS quality rating criteria comprehends 18 quality characteristics. However, MARS does not support developers in identifying the key aspects of application quality. Therefore, to search and pick up an appropriate subset of variables is a combinatory and optimization problem. We propose an unsupervised feature selection to identify those key quality features. So, second point, the method. The method that what we use is this figure 1. So the first component is the Mars data subset, and in order to evaluate this subset, we use a clustering K-modes algorithm. And to qualify the quality of the clustering, we use an index to check the quality of the cluster. And based on this index and based on the number of features, we build the objective functions that is used by multi-objective evolutive algorithm in order to produce and evaluate each solution. And with those new proposed solutions, we do this process in an iterative way until a specific number of iterations until and finally, we have the best solution. So next, I am going to explain briefly each component. So Mars dataset is a subset of data that you can classify by specific variables, that each variable is a specific feature for software. And it is grouped in different categories, from engagement, functionality, aesthetics, and information. And each application is evaluated with these subcategories. For us, is each subcategory is our variable. And we use a list of 565 applications collected during the last 20 years. And the scale is from 1 to 5. The second component is the K-modes algorithm that we try to find the best group in order to measure the distance between each element of the group with a proposed center. So we measure that distance, and the algorithm measure that distance and try to group those elements. The DB index is a Davis Baldwin index, is the quality of the clusterization measured by within distance. Each element that belongs to each cluster, the index measured the within distance and also the distance between clusters. So in that way, we can get a value for the quality of the clusterization. So the multi-objective evolutive algorithm works in this way. The algorithm proposes a specific solution that is a different combination of variables, and with that, the algorithm selects the parents, and after that, algorithm uses the recombination and mutation operators in order to produce new offspring, and this offspring is evaluated with the fitness function that I mentioned. We get the new generation, and also in this iterative way, after a specific number of generations, we get the final solutions. The representation that we use is a binary representation. So for each location in the representation represents a specific variable from the model. And 1 means that this variable is selected, and 0 is not selected. The fitness function is expressed by this formula. We have the F1 try to measure the quality of the clustering. So we have the index divided by the number of features, and F2 is the number of features that the specific solution has. So the idea is to minimize those fitness function simultaneously. So results. In this part of the figure, you can see the all results that we get from all runs in the last generation. And here you have the number of features, and here you have the index. So you can see that we have many solutions. But we are interested also in the best, absolutely best solutions from the last generation that we call Pareto optimal set. So each point that you can see here is a specific configuration of the combination of the variables. So we are interested to analyze this. We analyze those solutions by this graph. That is the genetic expression, when in the row, in each row represents a solution and each column is a specific variable. And so for dark color is this variable is selected and pale color is not selected. And that way we can check if we can find a specific pattern in the Pareto optimal solutions. But the best way to analyze this is in a variable frequency distribution for each variable in the Pareto optimal set. And we are interested to check which variables are above the 80% of the frequency distribution. So in that way, we can select these variables, and these variables belongs to engagement category that is related with fun, interesting, customizable, etc. Aesthetics, that is graphic design, overall visual appeal. Information, that contains high quality information from a credible source. So in that way, we can filter from 18 variables to those variables. As a specific example, we choose only 2 applications related with children with Down syndrome, and evaluate the applications according to the variables that we select. So in that case, for example, if you check this application, is only this is the screenshot of the main interface. So, and we evaluate this according the variables related with information. And you can see that, for example, variable 17, that is related with visual, means that visual explanation of concepts through charts, graphs, image, and videos. And the value is 3, that means okay, but often it's unclear, confusing, or wrong. That means that probably this interface is not good for a specific kind of user, especially with some Down syndrome. The next application is different screenshots from applications that try to teach some specific problems from basic mathematics. And in that way, you can see that we have more information about the task, and also how to achieve the task and how much the task was achieved. I mean, there is a measure. So in that case, for example, variable 14 goals means that it's measurable and achievable, and the app has a specific and measurable goals. So for conclusions, the evolutionary approach converged correctly, exploring optimal solutions where the essential features arise. 7 features that belong to engagement, aesthetics, and information category are the most frequent. And information category variables become an essential group to consider to improve mHealth's apps quality. So, thanks.
Thank you, Rolando. Pancham, if you have any questions, or if anyone from the audience has any.
I don't see there is any question in the chat. Very nice presentation. I have just one question for the presenter. You are using genetic algorithms. Is this to update your original database, I guess? Oh, you have to unmute your microphone.
Sorry, could you repeat the question, please? I couldn't understand you.
Okay, I think you're using the soft computing genetic algorithms. The
Okay.
purpose of this is to update the original database.
No. The purpose is only to try to check which combination of the variables is the best combination in order to get more cohesive clusters, in order to check if that combination of features is good or not good. So that is the purpose of the algorithm. Because if you try to find a specific solution, you have many combinations of the variables, and that is not possible to do by an exhaustive process. And for that reason, we use a multi-objective evolutionary algorithm.
Thank you.
That's perfect. Thank you, Ronaldo, for your presentation. And if anyone else in the audience does have any questions, please use the chat function. So I'm just going to share my screen now. So we're going to move on to our next presenter, who is Christos Mourizos, and he's from the Aristotle University of Thessaloniki in Greece, and his paper title is Non-Uniform Electromagnetic Band Gap Lattices, a rectangular application.
Good evening to you all. Can you hear me?
Yes, we can.
Okay. Can you see my screen?
I can't see your screen at the very moment.
Yes, you can share your screen. Nahid, please stop sharing your screen so you can share.
Okay.
Yeah.
Perfect.
So good evening to you all. My name is Christos Mourizos from Aristotle University of Thessaloniki. And the title of this presentation is Non-Uniform Electromagnetic Band Gap Lattices, a rectangular application. The co-author of this paper is Professor Catherine Siagavara. The presentation outline begins with the target of the work, the concept of non-uniform EBG surfaces, the synthesis of the rectangle and the calculation steps, and finally the results and the conclusions. The target of the work is to design a rectangle that has a low profile, high gain at 868 megahertz, high VOC at the same frequency, and DC voltage at the output of the rectifier, and power at the input of the rectifier as high as possible, again at the frequency of interest of 868 megahertz. So first of all, let's explain what is a rectangle. It comes from the words rectifier and antenna. It is actually a system that transforms RF power to usable DC power. The front-end subsystem of a rectangle is an antenna which actually captures the surrounding RF signal and directs it to a matching network if it is necessary, which optimizes the power transfer from the antenna to the rectifier. The rectifier is a unit that transforms AC signal to DC. And finally, we have the energy storage unit. Secondly, let's explain what are the electromagnetic band gap structures. They actually belong to the wider family of metamaterials. They are two-dimensional periodic structures consisting of identical and equispaced metallic patches. And you can see these are the blue patches. And above and below them, we have metallic pins, the viases, which are connected to metallic ground plane, and all of them are embedded in the electric layer. Their basic attributes that makes them attractive for modern microwave application is their ability to suppress surface waves and the fact that they introduce zero reflection phase. It has been proved that antenna systems with EBGs yielded structures of low profile, high gain, and frequency bandwidth, enhanced polarization characteristics, and pre-specified radiation patterns. However, our research focused on non-uniform EPGs. The difference from the aforementioned uniform ones is that their patches, as you can see, are not identical and not equispaced. The reason we make this modification is in order to change the reflection phase across their surface. So the reflection phase is point sensitive in this non-uniform EPGs. So let's see the mechanism of the reflection at non-identical EPGs. The equal phase wavefronts of the reflected rays depend on the reflection phase at the point of incidence. So if this phase is graded from point to point across the surface, the rays reflected to different points of the surface are not parallel, even if the incoming wave, which are this one, are plane. So in this study, we exploited this unique attribute to create surfaces with proper geometry in order to focus these reflected rays at a specific point F of a specific distance above the non-uniform EPG. So when a plane wave is incident perpendicularly on this surface, the angle of reflection depends on the point of incidence given by this formula, where delta phi is the difference between the reflection phases of adjacent patches of interdistance delta x, while the reflection phases of the M cell is given by this formula, where ZSM is the surface impedance which changes from point to point of the N cell depending on the geometry, and N is the wave impedance of the area above the EBG surface. So by properly combining the values of the structural parameters of such device, we can actually achieve focusing of the reflected rays at a specific distance ZF under this condition, where xn is the distance of the nth cell from the middle of the array. So the concept behind these designs is to position a dipole or any other kind of antenna at this specific point of focusing in order to increase the gain and harvest more of the surrounding radiation. The methodology steps followed are: first, we designed the antenna system in order to achieve maximum VOC induced voltage VOC induced at the dipole's open circuit terminals when the entire system operates as a receiver at the frequency of interest of 868 megahertz, verifying actually the focusing phenomenon. Then we made the choice of a rectified circuit type and designed the matching network. And finally, we calculated voltage and power at the rectifier through circuit analysis. This is the proposed design. This is a single focusing cell, as shown previously. These are the reflected rays all gathered at this specific point F. It is a single focusing area. It consists of 3 non-identical patches and a mirror that thus we have a symmetrical area of totally 6 patches. The blue layer is the substrate, and on top of it we have a second, the yellow one, the substrate cover, which cover all the patches. Our structure, the proposed structure, is composed of 7 such focusing areas. As you can see here, this is a panoramic view of just the metallic lattices of the patches, and this is the dipole, which actually collects the reflected rays across its length. And this is a side view of the structure. The blue layer is a substrate layer. On top, we have the cover layer, and at a distance h d, we have the dipole. These are the structural parameters and their values of the final proposed design. All these parameters were modified via iterative simulations with intent to maximize VOC at the open terminals here of the dipole, treating the whole device as a passive receiving element with incident waves on it of field of circular polarized waves of field intensity of 1 voltage per meter. Later, having defined the parametric values, we approached the device, the whole structure via the equivalent circuit analysis in order to calculate the power and the voltage at the rectifier. This is the equivalent loop circuit without the matching network. This is the antenna, which is actually equivalent to a voltage source when it is treated as a receiving element and its input impedance. This is a coaxial cable which connects the antenna to the rectifier, and Z-rec is the impedance of the rectifier. The rectifier was chosen to be a full wave rectifier, consisted of 4 Schottky diodes, as you can see here, connected to a smoothing circuit of a resistance of 10 kilo ohm and a capacitor of 1 nanofarad. After calculations, it was found that there isn't any matching between the antenna and the rectifier, so we added, as you can see here, a matching network consisting of an inductor and a capacitor in order to provide matching between these two elements, the antenna and the rectifier, consisting of a capacitor of 0.7 picofarad and inductance of 117 nanohenry for matching at, again, 868 megahertz. Beginning with the results, first of all, as I mentioned earlier, our initial scope was to find the height at which the dipole's height at which the voltage of the VOC, the voltage VOC at the antenna input terminals is maximized. It was found to be at 13 millimeters, which actually we wanted to see a maximum here. It is where the focusing phenomenon takes place. So this maximum validates the focusing phenomenon. It actually implies an amplification of the voltage, since at this point, as you can see here, VOC at the input terminals of the dipole reach 1.76 volts. Given that the incoming, the incident waves at the structure was of field intensity of 1 voltage per meter. So later we fed the antenna, the dipole, in order to extract the input impedance versus the frequency. These are the results at the center frequency of 868 megahertz. And then we simulated the 3D radiation lobes for 7 frequencies around the frequency of interest in order to see how it radiates power. Values, gain values exceeding 8 dB were observed, as you can see, which is relatively high, and most of the power is gathered at the broadside direction. Later, we approached, having defined all the structural parameters, we simulated, we approached the structure in real propagation conditions for several directions of arrival, as you can see, and for different planes of the incident wave, in order to see how VOC, voltage VOC varies. As you can see, in all cases, maximum VOC occurs at 168 megahertz, since this is what we wanted, and the whole structure is designed to resonate at this frequency. And in most cases, VOC exceeds 1 voltage, 1 volt. For comparison reasons, the same dipole over a perfect electric conductor is exhibited here, as you can see. Given that we don't have any focusing phenomenon for the perfect electric conductor case, there wasn't any amplification. And again, for an incident wave of 1 voltage per meter, again, we receive 1 voltage. Then, through circuit analysis, we calculated voltage and power at the rectifier by these two formulas. Again, maximum values were observed at 868 megahertz. The calculations were made for the same values of directions of arrival as mentioned earlier in the VOC case. And again, as you can see, for both cases, maximum values occur at 868 megahertz. Finally, we made the statistical analysis with these two box plots for the two magnitudes, the voltage and the power and the rectifier, for 168 values for different directions of arrival and frequencies around 168 megahertz. For the DC voltage at the rectifier, mean value reached 466 millivolts. Maximum value reached 0.9 volts, and 50% of the values range from 0.35 to 0.5 volts. For the power case, mean value reached 16 microwatts, and the maximum value was found to be 68 microwatts, and 50% of the values range from 9 to 26 microwatts. Concluding, the reasonable assumption that non-uniform EBG structures can enhance the performance of a dipole-based rectenna, leveraging the focusing phenomenon, was verified. Gain values exceeded 8 dBs at the center frequency of 868 megahertz. Was found. The non-uniform EBG allows low-profile designs, given that the dipole was placed only 13 millimeters above the surface. VOC values at the dipole's open circuit terminals reached 1.76 volts per meter, which implies actually amplification of the total electric field, in contrast to the uniform EBG or the perfect electric conductor. And the focusing phenomenon helped us to yield higher VOC and in turn VDC and power at the rectifier values. This research was co-financed by the European Union and the Greek national funds under the call Research, Create, Innovate. This is the end of the presentation. Thank you for your time, and I'm waiting for your questions.
Thank you, Christos, for your presentation. If Pancham or anyone in the audience has any questions for you.
I can't see anything in the chat, but it's very interesting presentation. It's nice, very complex topic, to grasp. But what do you think of a typical application of this?
The typical is to power low power remote devices or sensors or actuators. That this is the modern application of rectennas, usually applied in IoT applications. And this is why the frequency of 868 MHz was chosen, since it is used in many IoT applications which use remotely placed sensors. So a rectangle like this can be placed in such places in order to power low power IoT sensors, for example.
In general, if I ask a question, what would be the typical maximum efficiency of this system, would you consider?
It was found to be, for this specific device, it was found to be around 62%.
Quite impressive.
But of course, it varies from application and antenna, and all these parameters shown here, all these subsystems affect efficiency. The matching network, the antenna, of course, the amount of VOC, the amount of RF signal the antenna will capture. That's why we wanted to maximize VOC, actually.
Thank you.
I think we had one question from the participants as well. Does the resonant frequency determined by the antenna and the reflect design, or by the RLC filter?
Can you repeat it, please? If the resonant frequency is defined by the antenna or the circuit? Can you repeat it, please?
States it does the resonant frequency determined by the antenna and the reflected design, or by the RLC filter?
No, it is. It was. It is defined by the whole structure. All this as a whole, all these patches and all these parametric values actually make this structure to resonate at 168 megahertz. And with a dipole placed on top of it, it was taken into consideration in order to resonate at this frequency. And actually, it was our initial goal to make the structure resonate at this frequency and actually maximize VOC at this frequency. And later, the matching network was designed based on this structure in order to provide matching at this frequency.
Okay, that's brilliant. Thank you very much, Christos, for your presentation, and obviously the answers to the questions as well. I think next we're going to move on to Mir, and I think, as we can see on the chat, Professor Zlatinka's paper will be moved to the end of the session. So, I'm just going to share my screen quickly. Our next presenter, Tamir Qasim, from the Nile University in Egypt, and his paper title is Systematic University Decision Making Based on Footprint Identifiers. So Tamir, whenever you're ready.
Yes, I'm ready. I'm ready. Shall I share my screen?
Yes, please.
So I believe I should finish in 10 minutes my presentation. So I will start. So can you see my slides?
Yes, we can see your slides.
Okay. So thank you very much for the introduction. My name is Tamir Qasim. I should present the results today by this large team of 6 members. I would like to acknowledge the participation of Professor Wael Aql. He is the provost of Nile University, among the other teams, of course, among the rest of the team members. The presentation should go like this. We'll have an introduction, methodology, and then I will describe what's the meaning of the footprint, correlation of the footprint in detail, and then I should go into the conclusion section. Now, this is regarding the introduction. The main theme is decision making. Okay, and as a rule of thumb for decision making, the well-known algorithm is the balanced scorecards. The balanced scorecards assume that we take the decision based on 4 dimensions, either the customer or the internal process, or through learning and growth of the institute, or to satisfy the financial stakeholders. In fact, this widespread methodology suffers from 3 main disadvantages: is that we do not have any clear justification for selection of these 4 pillars. Also, diverse stakeholders are ignored since we are just focusing on the financial stakeholders. Finally, we don't have clear recommendation systems. It is just based on interpretation of the aim of this paper is to get an alternative for the balanced scorecards, or to improve the balanced scorecards within an academic system.
I think we were running into some technical issues with Tamir.
Yes, Tamir is back.
I'm sorry. I hope I'm back.
Yes, we can hear you now.
So I hope I didn't lose much. Anyhow, I was speaking about the academic quality requirements, academic quality and accreditation requirements. They should provide nice guidance for the decision maker. However, we don't have a direct link between the decisions and the inputs of the outputs of the quality system. The leadership has direct interface to what's called the process. The process is any set of interrelated activities which achieve something useful. However, we don't have a clear relationship between the academic quality and accreditation requirements and the processes. So here comes the role of the footprint. The footprint is a system to characterize each element, either a process or an academic quality system or academic quality requirement with a concise set of fields. In fact, the main hypothesis is that if we are having 2 elements having close footprints, then they should be well correlated together and we can control them together. The procedure is the following. We should determine the footprint for each academic quality requirement and for each process. Then we should calculate the correlation, and then we should identify a set of processes A that is correlated to the academic quality and requirement B. And to improve item B, we should work on the set of processes A. I hope this is clear enough. So I will go further now in through the methodology. We are focusing here on the Egyptian academic quality and accreditation requirement system. In numbers, we are having like 24 governmental universities in Egypt, with 26 private and non-governmental universities. We are having 120,000 faculty members. I'm just illustrating the impact of the academic quality system in Egypt. We are having 12 main standards: planning, leadership, quality, and so on. I'm just also here explaining how it is complex to improve about 89 standards within the framework of the university processes. So this lends us to the concept of the process. Just to illustrate, consider the freshman recruitment process. The output of this process is the number of the new enrolled students per academic year, and the inputs should be the allocated resources, either the working hours or operation budget. The activities are diverse, and they include orientation, entry exams, application verification, and so on. So the question is, which academic standard is related to this process, the freshman recruitment process? I will skip this. Let us go back to the methodology of the footprint. The footprint idea is similar to the idea of identification of each citizen, for example, by the given name and family name and date and location of birth. We assume that two citizens can never share the same information. However, this is not true because we will always have some probability of duplication. However, we can ignore this, and we can assume that this is effective. So the same that's occurring here, we assume that, I'm sorry, I don't know why the sharing stopped. I will share again. So this is the main fields that we use to identify each element: the service provider and the beneficiary and the function and the output and the area of relevance. Okay. In fact, to identify this system, a collaborative work of dozens of brainstorming workshops were done with participation of many sectors, either faculty or leadership, and also participation on international level from experts in Egypt and Spain, United Kingdom, and Sweden. This was facilitated in the framework of the international funded Erasmus project. So I will have to skip this, but this is the output of the mapping of the or listing of the footprint. We are having tables. These are the possible values for each field in the footprint. Okay. Next, let us explain briefly the footprint correlation algorithm, because now it includes much mathematics. Simply, we compare each two elements, and if the two elements are different, then the correlation is the zero on the sub-element level, and still we can make some distance between them. And then for this matrix, we can get the maximum for each row and the maximum for each column. And then we get the average of these maximums. And then we can get the overall correlation between two elements. I'm sure that this is very brief, but I'm running out of time, so please excuse me. Finally, this is an example of application. I'm having now 6 academic standards mainly related to the satisfaction of the students. And I'm having here a sample of 14 processes extracted from an academic system. And these are the results. We are having here a decision matrix. The decision matrix highlights the process that's well used to control or to improve the standard. For example, process 1 should control very well standard 3 and standard 4. Process 2 can be used to control standard 6. And for example, process 10 is totally irrelevant to these standards. Okay, this is the output of the decision matrix. As we can see, this decision matrix provides the decision maker with very solid grounds for having clear decisions. Fine. My conclusion briefly is that the next step, this work should be extended to yield quantified decisions as process inputs. And also, I am planning to, I will try to implement the optimization using the simplex. Finally, this is the acknowledgement again that this work was funded by the European grant of the Academic System Resource Planning, the ASRP. Thank you very much, and sorry for the extra time.
Thank you, Tamir, for your presentation. I think we're just going to wait on Pancham Shukla for a second. I think he's disconnected from the call, so I'll just give it a couple seconds. But if anyone in the audience in the meantime has any questions for Tamir, then please go ahead in the chat function. So we're just going to move on to our next presenter. So our next presenter is Darren Muscara from the Universidad of Distro Francisco Jose de Caldas in Colombia, and his paper title is called Integrated Management System for Self-Sufficient and Energy Sustainable Buildings. So Darren, over to you whenever you're ready.
Here, I am here. Already the presentation.
Perfect. Now we can see.
Yes, yeah. You see the presentation?
Yes, we can see the presentation.
Yes. I'm going to start. Good day, a cordial greeting from Colombia. I have the pleasure to introduce you some result of research project entitled Integrated Management System for Self-Sufficient and Energy Sustainable Building. My name is Darren Muscara. I'm teacher, Distrital Francisco Jose de Caldas University, and they must tell you that the present project has been working with the Anomalies and ECCA University. Below is agenda of the presentation. In this slide, we can see the general case of the integral management system for building. As can be seen, the system will have the application in the cloud computing scale that will have the following function: monitoring and forecasting the environment climatic condition. In this case, of the application, it has been developed for Bogotá, Colombia, but it can adapt to the other city and country. The application allows the management of alternative energy source for building. At this point, we have emphasized the management of distributed generation sources of renewable type, but not renewable sources that are alternative, such as diesel generator, microturbine, and other can be included. The management system controls some point load of the building, such as the lighting system and a smart elevator that are largely self-generating. Next, we will see a little more the detail is different line of the management system. As can be seen, the management system manages the alternative source of energy that are on the user of the building. Specifically, the generation condition of each source are reviewed at the corresponding activation or desactivation of a parallel box is carried out that can partially or totally fit building. Of course, everything is subject of the availability of the energy resource, such as solar radiation, the wind speed, and the level of precipitation during previous day in real time. For this research, we had the user photovoltaic and wind speed and urban type hydroelectric center to take advantage to the rain regime that occurred in Bogotá for several months a year. We will see the more detail now. Here, we have the management system for the weather sources. As can be seen, there is a pipe system on the left side that called gray weather, water weather from the washing basin, and the lax rinses for the washing machine for each floor of the building. And pipe system carried out the gray weather to the top and accumulate in the underground tank, where a particular level is defined according to the need to each building. And in times of high rainfall, I can be direct through a high pressure bypass pipe that feed a Pelton turbine connect to the synchronous tide generator that after obtain alternative energy rectify and storage in a battery store that then taken to a DC AC inverter circuit. Here, we observe that the management system can control the light of the building. For this, we have the relays and natural light application system. In Bogota, for example, the irradiation level are particularly high, since we are 2,600 meters closer to the sun. On the roof of the building and some perimeter point, we have installed light concentrating lenses that receive solar radiation and then channel it through single mode fiber optic to point inside the building. Well, now we'll analyze the inclusion, the self-generation elevator. The research carried out the evaluation of vertical transport, the building in the center in the city of Bogota. Permanent magnet of the neodymium type has been installed in the external part of the elevator cap that allow the raising and lowering of the car to generate an induction process and in a hole that located in the elevator shaft. The voltage is induced in a coil that then is stabilized, then rectified and stored in a battery to then be taken to a DC AC inverter power the internal elevator line, your internal communication system, and in some case, the elevator electric motor. The communication system proposed is a support for management of the building. Is structured with two communication channels, PLC system, power line communication, and conventional wireless Wi-Fi. The communication system allows the sending and read between user and general management system, allow they to be obtained or the location or the user at the climatic condition of the places. Well, all control system for building load uses 34-node text network. Here is a table. You can see the characteristics of the load. Here we indicate the active or reactive power each load. In gray, we have included the load building that are managed by the comparative management system. In this slide, we can see the vector of daily energy demand in the table. On the right, and that the graph corresponds to the dark blue line. Then you see the decrease in consumption when you apply control of the orange line lighting system, is this line. Later, when applying the gray line, smart building management, is this line. Subsequently, the decrease in consumption is seen when the alternative generation source are activated for a typical day as the yellow line reference, is this line. And finally, the decrease in demand is seen the light blue line when all the control and self-generating systems are applied, that they are managed via the web. That's all the content. Thank you for your attention. No more.
Thank you, Darren, for your presentation. Move to Pancham or anyone in the audience who has questions.
Thank you. I think it was a fantastic presentation. Enjoyed.
So if no one has any questions, thank you very much for your presentation, Darren. So we're just going to move to Zlatinka, who we were meant to have earlier. So I'm just going to share my screen really quickly. So so Zlatinka, just to remind you, she's from the Bulgarian Academy of Sciences, and her paper is a multi-dimensional rendering of error types in sensor data.
Hello, everyone. Are you hear me?
Yes, we can hear you.
Okay, because Professor Kovacheva has some technical problems, I will try to present this research. I'm sorry for all troubles. I'm also not in my working place, so I prepared a short presentation and will not share my video just to be sure that everything with the presentation is okay. So can you see the presentation?
Yes, we can see the presentation.
Okay. So Zlatinka Kovacheva, Ina Najdenova, and me, we working together for more than 20 years. And during last several months, we focus on the data quality in different areas. So this article is focused on data quality in wireless sensor networks. Because different types of errors that occur during the operation of networks could be discussed. We analyzed different types of errors and propose an approach based on multidimensional organization for the rendering of different wireless network types. First, let's say that the very fast development of this network raises a lot of challenges. They are used in different fields of our life, such as industry, smart cities, agriculture, healthcare, transport, etc. But the reliability of this sensor data is often a challenge. There are many cases when almost half of the collected data is faulty, and in this way it cannot be used for meaningful interpretation. Here are listed several reasons for poor data quality, like lack of measurement, inconsistent or duplicate observation, lack of sources, aging of the sensors, security breaches, and some others. Speaking about the data management aspects, we can two main aspects in these networks, data quality assessment and data cleaning technology. Also, we can differentiate several data flow layers for applications that use data from different sensors. The perception layer, this is the physical layer that consists of various types of sensors. On this layer, the sensor devices measure and collect readings. The network layer is responsible for the transportation and processing of sensor readings collected in the previous perception layer. And the application layer that deliver application which can be used by different end users and which are responsible for network data storing, processing, and analyzing. Speaking in terms of mathematics, if the sensor operates normally, its work could be presented in this equation where are captured the sensor output and time and the denote noise. The most commonly addressed sensor data quality errors are different types of faults and anomalies in the sensory outputs followed but by the lack of data. Faults are deviation from the normal operation of sensor outputs. Later, we will mention several classification on these faults that could be intermittent, persistent, or transient. Sensor faults can also be categorized according to their divergence from the normal operation. On this slide, we can see the most typical sensor faults in the first perception layer. Noise error, constant offset error, continuous or continuous varying or drifting errors. On the next slide, several other typical errors are presented: crash or jammed error, clipping error, outlier error, and the list continues with spike faults, missing values, and some other types. On the network layer, the most typical communication faults concern omissions that would occur when sensor readings are missing because of lost message or crash defaults. Crash can occur during the transmission and or communication. Also, delay faults, which rely on current and up-to-date sensor data, that provide quality services, message corruption, when some communication fault leads to corruption between different sensor or between sensor and application. Some of errors of sensor data could be can be spread to the subsequent layers. So for this reason, it is important to eliminate sensory data quality issues at the lowest possible level. And this was important because at the application level, the most common sources of errors are program bugs and limitation in data processing. But the probability of occurrence of such types of data are relatively small when we compare with them with other types of faults. In general, the errors in the sensor network data could be divided into two large classes: intentional or unintentional. Intentional data errors can be caused by malicious attacks over wireless networks, while hardware failures, sensor malfunctions on some others are more caused unintentional data errors. According to the frequency of occurrence of data deviation, the errors could be classified as random errors, systematic errors, and spurious readings. Of course, the systematic errors need special attention, while the random errors reflect different variation in random direction. Depending on the nature of the anomaly, outliers can be classified into three main categories: point outlier, contextual outlier, and collective outliers. Outliers can be categorized also into two general types: global or local, depending of their scope. Local outliers are determined based on data collected by a particular sensor node. On the other side, the global outliers are determined in more global context in entire network. The outliers also can be classified to their, according to their source. Several general sources of data anomalies can be differentiated here: events, when something suddenly changes in the environment; malicious attack, when network struggle from security issues; and noise and errors, when these outliers are a consequence of noises in measurement or reading coming from detective sensors. So all these different errors that we differentiate from different sources, they lead to different data quality issues. Based on our previous research and using different classification, we can summarize that the most of the problem in the field of sensor networks data are related to accuracy, completeness, consistency, and timeliness. I should mention here that this categorization is based mostly on sources in the literature. However, depending of different type of the sensors, we now see that many new devices arise every day. The classification could be more strictly provided in case of specific sensors. Based on this reviewed classification and different criteria, we propose an approach based on the creation of multidimensional cube of sensor errors to observe different assessment measures for each type of errors. This figure illustrates a simple model of a three-dimensional cube focused on three criteria. Most typical sensor fault and outliers, network segment, and the period of time. Of course, we can add more dimensions related to other criteria like frequency, behavior, type of fault factors, layers of error occurrence, reason for the fault, and some others. Depending on the research need, this cube may contain more generalized and aggregate information, or to include dimensions that with a greater level of detail, or the lowest level of detail when we address particular sensor nodes and track hardware configuration and instrument features. So the most important factor here is to establish a real connection between the occurrence of errors and the reason for its happening. The accumulation of information about the occurrence of errors in sensor data will help to better understand how deployment context affect the measurement quality. For instance, monitoring the concentration of certain type of errors in a given segment of the network will trigger a deeper investigation of the factors that are specific to that segment that contribute to the
sorry, Kalinka. Sorry, Kalinka, but can you please conclude?
Okay.
Thank you.
I have 2 slides in conclusion. So the most important are the future expansion of this multidimensional model. So we propose here the next dimension to be connected to methods for error detection, for methods for error correction, and for error clearing status. And in conclusion, I can say that we propose a model that presents the error occurrence in sensor data in a multidimensional manner, and this model will allow to quantify errors of sensors and to analyze the reasons for their appearance. And one of the advantages of this model is that it is open and will allow the construction of multiple hierarchies to reflect other types of taxonomies depending of the goals of the analysis. So thank you for your attention.
Thank you, Kalinka, for your presentation. If anyone has any questions from the audience or Pancham in regards to that paper.
Right, I think this is nice. My only comment, it's not a question, is a nice presentation, especially multi-dimensional rendering of the error types. It would be interesting to see the visualization of those errors of the hypercube. In itself, it would be a subject. Very well
Yes, I
presented.
know, but we are at the beginning of our research, so we consider this visualization, but as the next step. Thank you for your remarks.
So that's perfect. If anyone does have any further questions, please use the chat function. I sincerely thank our authors for their excellent presentation and contributions in this session, and all of our participants for being part of this international conference. I hope the session was informative enough. All the presenters will be getting their digital certificates through the email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of WS4 2021. I also would like to thank our session chair, Dr. Pancham Shukla, for chairing this session. I'm just going to quickly share my screen here. Hopefully you can see that. So this is a token of appreciation to the chair on behalf of Team World S4 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence. So I would like to kindly request everyone to turn on their camera for a quick snapshot of the virtual conference.
Yes, by the time, yes, Dr. Pancham, if you want to share a few words with authors.
Yes, thank you. Thank you for giving me this opportunity to chairing the session. I actually witnessed a range of papers with different subjects ranging from energy management, even physics, combining IoT, wireless systems, and so on and so forth, perfectly fitting to the overall theme of the conference. And it was very enjoyable presentations, and I will take quite a lot with me. So thank you all the presenters for presenting various topics beautifully. Thank you.
Yes, thank you, Dr. Pancham, for chairing this session. Thank you. Now we request everyone to just turn on their camera for a group photograph, the digital group photograph, just for the memory. And this also we will share with everyone later on. Yes, Nahid, can you please take a photograph?
Yeah.
Yeah, Sarah is. Yeah.
So yeah, that's all done. Thank you everyone, and stay safe and take care.
Yeah, and hope to see everyone next year in physical mode. Bye.
Thank you for the good session. Bye.
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 Thank you.
Thank you. Take care.